state that a covalent bond is formed when a pair of electrons is shared between two atoms, leading to noble gas electronic configurations. What is covalent bond? Covalent bond involves sharing of electrons between non-metals. It involves sharing of electrons between non-metals. Remember, covalent bond is always found between non-metals. Note this point. Covalent bond is always formed between non-metals. Why atoms form bond? Atoms form bond to complete its valence shell. Atoms form bond to complete its valence shell. Now, if recalling, valence shell is the outermost shell of an atom. Valence shell is the outermost shell of an atom. Now, whenever an atom completes valence shell, this results in noble gas electronic configuration. So you can also write in order to have stable arrangement of electrons. So for this statement, to achieve noble gas electronic configuration. You can also write to have stable arrangement of electrons. Have stable electrons. Which elements form covalent bond? Covalent bond is formed between atoms of the same or different non-metals. Covalent bond is formed between atoms of the same or different non-metals. This results in the formation of molecules or group of atoms. This results in the formation of You see in this periodic table, this is the periodic table. These all are metals. The blue area, it contains metals. And these all are non-metals. Now I have divided these metal and non-metals through purple line, which is staircase line. The staircase line starting from here. So here we are having metals. And here we are having non-metals. So the better idea, we are concerned with this one. We are not studying metals. Purple line divides metal and non-metals. We can say above this purple line, which is staircase line, above staircase line, there are non-metals. Below staircase line, we have metals. Now let's see some examples of covalent molecules formed from atoms of the same element. H2, O2, N2, Cl2. These all are examples of covalent molecules in which atoms of the same element involved. Now here are some examples of covalent molecules formed from atoms of different elements. We have common examples from everyday life, which is water, H2O, methane gas, which is used in our stoves and heating purpose, or in CNG cars, ammonia, NH3, HCl, hydrogen chloride, which on dissolving in water produces hydrochloric acid. Methanol, CH3OH, used in hospitals. C2H4, it's ethene, it's used in the manufacturing of alcohol. Carbon dioxide, and there. So here's a learning outcome for this lesson. Describe the formation of covalent bonds in simple molecules, including H2, Cl2, H2O, CH4, NH3, HCl, CH3OH, C2H4, O2, CO2, and N2. Use dot and cross diagrams to show the electronic configurations in these and similar molecules. Here is the periodic table. First of all, I'm going to draw the staircase line so you have better idea of about the position of metals and non-metals. So in this area, we are having only non-metals. This is above staircase line. In this area, we are having only metals. Remember, this last group is inert gas. This group is inert gas or noble gas. Does not take part in bonding because they neither share electrons nor lose or gain electrons. This topic, we are concerned with the non-metals only. This is some examples of the covalent bond or covalent molecules formed from atoms of the same element. I gave you some examples in the last video. H2, O3, N2, F2, etc. You see, they all have atom of the same elements. Those atoms of the hydrogen, atoms of hydrogen. And in this one, you are having atoms of oxygen. In the same way, in N, you are having atoms of nitrogen. And in F2, you are having atoms of fluorine. We'll see some examples of covalent molecules formed from different elements. H2O, we have atoms of hydrogen and oxygen. In the same way, you are having other examples like NH3, where you are having atoms of nitrogen and hydrogen, HF, atoms of and H. This HF, you are having atoms of H and F. CH3OH, C2H4, SO2, etc. Many examples. Now, before proceeding, I want to recall the concept of valency. It's very important to know the concept of valency because this will help you in predicting the chemical formula between atoms of different elements. Valency is the combining power of atom. Valency is the combining power of an atom. It helps in predicting the formula. Fine. So for different groups, there are different valencies. For example, for metals, these are the valency for metals. We know these are metals. 1, 2, 3. Here's +1, +2, +3. For non-metals, 4, 5, 6, 7. 4, we have 4 valency. We have plus -4. Here we are having -3. Group 5, group 6, we have -2. Group 7, we have -1. No valency for group 8, as I told you that they do not take part any in the formation of bonding. See one thing, that for metals, the valency is equal to the group number. The group number indicates the number of valence electrons, which means these are the electrons which metals are going to lose. So these become their valency. So it's easy to predict the valency for metals, group 1 till 3. But what's happening from group 4 till group 7? The valency will be equal to the number of electrons they are going to gain. Like, leave group 4, they have +-4. The reason is that they contain both non-metals and metals. So some are losing 4 electrons, some gain 4 electrons. For group 5, they gain 3 electrons. They need 3 electrons to complete their valence shell. That's why the valency becomes 3. Also, the sign is minus, which indicates they are going to gain electrons. For group 6, it's -2, which indicates that they are going to gain 2 electrons. Group 7, they're going to gain 1 electron. That's why it's -1. Now let's do some working. Let's predict the formula between oxygen and chlorine. Oxygen, the symbol for oxygen is O, and chlorine is Cl. Oxygen belongs to group 6. Here's oxygen. Here's oxygen. And here's chlorine. So let's write the valency for oxygen, group 6. Valency will be -2. Chlorine, group 7, -1. Ignore their charges, and these number becomes their subscripts. These subscripts will be exchanged. The final formula will be OCl2 or Cl2O. Name is dichlorine oxide. Dichlorine oxide. You can even call it oxygen dichloride. Oxygen dichloride. Di means 2. There are 2 atoms of chlorine involved in this. That's why I'm writing di. Now let's work out the formula between carbon and fluorine. Carbon belongs to group 4, so valency will be +-4. Fluorine belongs to group 7, the valency will be -1. Ignore their charges. Now these subscripts will be exchanged. So there will be 1 carbon and 4 fluorine atoms. So we have CF4. We call it carbon tetrafluoride. Tetra means 4. Tetra means 4. We write here mono means 1, di means 2, tri means 3. Just for your knowledge. Recall the positions of metals and non-metals in this periodic table. Here we are having metals. We are having non-metals. This is staircase line. The purple line divides metal and non-metals. In this video, I will show you how you can predict the formula between different group elements and hydrogen this time. Hydrogen, the valency of hydrogen is -1. The symbol is H, its valency is always -1. There's other valency also, it can be either -1 or +1, but we'll consider it as -1. So I want to predict the formula between carbon and hydrogen. C is the symbol for carbon, H for hydrogen. The valency of carbon is +-4. For hydrogen, it's +-1. Ignore their charges. These subscripts will be exchanged. It will become like this. So the final formula will be CH4. It is methane. Now let's do it with group 5, between group 5 and hydrogen. I'm taking nitrogen from group 5 and hydrogen. The valency of group 5 is -3, hydrogen +-1. Ignore their charges. These subscript will be exchanged. So the formula will be NH3. The name is ammonia. It's a compound used in the manufacturing of fertilizers. Now predict the formula between group 7 and hydrogen. I'm taking chlorine from group 7. Cl is the symbol. Hydrogen H. Ignoring their charges, the valency will be 1. If you will exchange these subscript, it will be like this. So the formula will be HCl. The name is hydrogen chloride. Hydrogen chloride on dissolving in water produces hydrochloric acid. The strong acid is produced in our stomach and helps in our digestion. The chemical formula between hydrogen and bromine, carbon and sulfur. You know the symbol and charges of hydrogen and bromine. Both hydrogen and bromine has a valency of -1. Just ignore their charges and these numbers will become subscripts. The subscripts will be exchanged. Let me do the working for you. H, B, R. Ignoring their charges, valency is 1. For subscript, these subscript will be exchanged. So the formula will be HBr. The name is hydrogen bromide. Next one is between carbon and sulfur. C is the symbol for carbon. S is the symbol for sulfur. Valency of carbon is +-4. So I'm ignoring its charge. I will write 4. And valency of sulfur is -2. Again, ignore its charge. So, but look at these numbers. These are even numbers. Then these will be divided by 2. What we will get? We'll get 2 and 1. Now, these subscript will be exchanged. We'll get this CS2. It is carbon disulfide. Carbon
carbon disulfide. As there are two atoms of sulfur, so I will call it carbon disulfide. The learning outcome is same for this lesson. That is describe the formation of covalent bonds in the simple molecules, including these molecules starting from H2 ending on N2. Use dot and cross diagrams to show the electronic configurations in these and similar molecules. Recall the valencies of non-metals only. These will be helpful in formula prediction and then dot and cross diagrams. I'm writing the valency for non-metals only, starting from group 4 and ending on group 7. Plus minus 4, group 5 minus 3, group 6 minus 2, group 7 minus 1. Now I'm drawing dot and cross diagram between oxygen and chlorine. The formula is Cl2O. Cl2O, which means there will be 2 chlorine and 1 oxygen atom. Remember one thing, and that is we will show only valence electrons. First of all, you have to show the key on right hand side. There are 2 elements, Cl and oxygen. I'm using dot for oxygen and cross for chlorine. An oxygen atom needs 2 electrons to complete its valence shell, while each chlorine atoms need 1 electron. Electrons will be shared in this way. In the center, you are having oxygen, 1 chlorine, 2nd chlorine. Now I am drawing their valence electrons. Oxygen need 2 electrons, so it will offer it 2 electrons to these chlorine atoms. 1, 2, 3, 4, 5, 6. 6 is the number of electrons that's present in the valence shell of oxygen, as it belongs to group 6. What about chlorine? Chlorine belongs to group 7. So it must have 7 valence electrons. 1 will be shared with oxygen atom. Let's start with this one. 1, 2, 3, 4, 5, 6, 7. Now I will do this for this chlorine atom. 1, 2, 3, 4, 5, 6, 7. If you count the total number of electrons in each circle, it will be 8, which means both oxygen and chlorine have completed their valence shell by sharing. Both oxygen and chlorine completed their valence shells by sharing. Let's try dot and cross diagram between carbon and fluorine, as we have already worked out the formula, which is CF4. This indicates that there will be 1 carbon and 4 fluorine atoms. A carbon atom needs 4 electrons to complete its valence shell, while each fluorine atom needs 1 electron. Now this time I'm using dot for fluorine and cross for carbon. The dot and cross diagram between these two will be like this. This is carbon, it's 1 fluorine, 2nd fluorine, 3rd fluorine, 4th fluorine. Let's write their symbols. First, I'm showing the valence electrons of carbon. It is in group 4, so there must be 4 valence electrons. 1, 2, 3, 4. Fluorine belongs to group 7, so each fluorine will show 7 valence electrons. Let's start with this one. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. You see, each of these atoms have completed their valence shell. They all are having 8 electrons in their valence shell, which means their valence shell is complete. They have just completed their valence shell, or you can say acquired the electronic configuration of inert gas or noble gas. Let's work out the dot and cross diagram between carbon and oxygen. We know the formula. It's CO2. CO2 is carbon dioxide. It means that there will be one carbon and two oxygen atoms. A carbon atom contain 4 valence electrons, which means it needs 4 electrons to complete its valence shell, while an oxygen atom has 6, and each oxygen atom need 2 electrons to complete its valence shell. So first of all, I'm drawing the key on right hand side, CO. I'm using dot for carbon and cross for oxygen. Here we are having carbon in the center and 2 oxygen atoms on right and left side, O, C, O. First of all, show valence electrons of carbon. There will be 2 oxygen atoms. Carbon atom will offer 2 electrons to each oxygen atom. 1, 2, 3, 4. Now let's place valence electrons of oxygen. It's in group 6, which means it has 6 valence electrons. 1, 2, 3, 4, 5, 6. Let's do this for this one. 1, 2, 3, 4, 5, 6. If you count the total number of electrons in each circle, it will be 8. Let me do the working for each oxygen atom. 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons. What about this oxygen atom? 1, 2, 3, 4, 5, 6, 7, 8. Again, 8 electrons. What about carbon atom? 1, 2, 3, 4, 5, 6, 7, 8. Again, it's also having 8 electrons. So all these three have completed their valence shells by sharing electrons. Recall the valencies of non-metals. I'm writing the valencies of non-metals only, so that it will help you to draw dot and cross diagram. Starting from group 4, plus minus 4, minus 3, group 5, group 6, minus 2, group 7, minus 1. We write valencies. In today's lesson, I will show you how to draw dot and cross diagram between hydrogen and different elements. Let's start with the first one, which is methane. The formula is CH4, which indicates there are 4 hydrogen atoms attached to 1 carbon atom. I'm showing valence electron for carbon with dot and cross for hydrogen. So here we are having carbon in the center, and 1, 2, 3, 4. These 4 are hydrogen atoms. The final dot and cross diagram will be like this. Let's show the valence electron for carbon atom. 1, 2, 3, 4. We know hydrogen has only 1 electron, so they all will share with carbon atom. 1 for this hydrogen, 1 for this hydrogen, 1 for this hydrogen, 1 for this hydrogen. So this is a final dot and cross diagram for methane. If you count the number of electrons for carbon, it will be 8. 1, 2, 3, 4, 5, 6, 7, 8. But for each hydrogen atom, it will be 2. 1, 2 for this hydrogen, 1, 2 for this one, 1, 2 for this one, 1, 2 for this one. So it means each hydrogen acquired the configuration of helium. Each hydrogen acquired the configuration of the electronic or electron configuration of helium. Now I'm drawing dot and cross diagram for ammonia. The formula is NH3. Ammonia. First of all, we have to show the key. For nitrogen, I'm using dot. Hydrogen, I'm using cross. You see, there's only one nitrogen, and nitrogen is present in group 5, which means it needs 3 electrons to complete its valence shell. So each hydrogen will share 1 electron with this nitrogen atom. Let me draw This is for the nitrogen, the first hydrogen, second hydrogen, third hydrogen. Let's show the valence electron for nitrogen. 1, 2, 3, 4, 5. For each hydrogen atom, it will be shown with cross. One for this hydrogen, one for this hydrogen, one for this hydrogen. Count the number of electrons for nitrogen. 1, 2, 3, 4, 5, 6, 7, 8. Which means nitrogen has completed its valence shell. Or each hydrogen got 2 electron its valence shell now. So all of these have completed their valence shell. Now I'm drawing dot and cross diagram between hydrogen and oxygen, which is H2O. You know the name of this compound, it is water. You know water is very important. We can't live without water. Oxygen belongs to group 6, which means it needs 2 electrons to complete its valence shell. Therefore, it will share 2 valence electrons with 2 hydrogen atoms. First of all, show key. On right hand side, we have oxygen and hydrogen. So I'm using cross for oxygen here and dot for each hydrogen atoms. So in the center, we are having oxygen. This is oxygen. This is hydrogen 1. This is hydrogen number 2. First, show the valence electrons of oxygen. 1, 2, 3, 4, 5, 6. For each hydrogen atom, 1 for this one and second for this one. You'll see all of these have completed their valence shell by sharing electrons. Oxygen got 8 in its valence shell now. 1, 2, 3, 4, 5, 6, 7, 8. And hydrogen got 2. Each hydrogen got 2. 1, 2, 1, 2. So all of these have completed its valence shell. Now here's a draw dot and cross diagram to show the electronic configurations between hydrogen and bromine. Recall the valencies of hydrogen and bromine. You know the formula between these two will be HBr, which means there is 1 atom of hydrogen and 1 atom of bromine. I will show dot for the valence electrons of bromine and cross to show the valence electrons of hydrogen. Bromine belongs to group 7, which means it needs 1 electron to complete its valence shell. And we know that hydrogen needs 1 electron. So final diagram, dot and cross diagram between these two will be like this. This is bromine, this is hydrogen. HBr. First of all, I'm going to show the valence electrons of hydrogen, which is 1. Now let's show the valence electrons of bromine, which is 1, 2, 3, 4, 5, 6, 7. You see, both have completed their valence shell. Bromine got 7 electrons, as it belongs to group 7. So it has shared 1 of its electron with 1 electron from hydrogen. Let's count the electrons for bromine. 1, 2, 3, 4, 5, 6, 7, 8. And for hydrogen, it needs 1 electron to complete its valence shell. This one belongs to hydrogen and this one is coming from bromine. So it has also completed its valence shell. Let's do the next one. Carbon and sulfur. These two will form the compound, the formula CS2. Or recall the dot and cross diagram of CO2, then it will become easier for you to draw the final diagram. I'm showing the dots for sulfur and cross for carbon. We have carbon in the middle. That's carbon. This is sulfur number 1, sulfur number 2. SCS. Now let's show the valence electrons of carbon. There are 4 electrons in carbon as it belongs to group 4. 1, 2, 3, 4. Now start placing the electrons of sulfur. It belongs to group 6. There should be 6 valence electrons. 1, 2, 3, 4, 5, 6. For the next sulfur, it will be 1, 2, 3, 4, 5, 6. If you count the total number of electrons in each circle, it will be 8, which tells that all these 3 have completed its valence shell. 1, 2, 3, 4, 5, 6, 7, 8. This one is for the sulfur. The next sulfur, 1, 2, 3, 4, 5, 6, 7, 8. Now let's count the electrons for carbon. 1, 2, 3, 4, 5, 6, 7, 8. So all these three have completed their valence shell. Now we'll continue the lesson with the same learning outcome, which is describe the formation of covalent bonds in simple molecules, including a molecule starting from H2 and ending on N2. Use dot and cross diagrams to show the electronic configurations in these and similar molecules. For your convenience, here's the periodic table so that you can recall the valencies of non-metals also. Only I'm writing the valency from group 4 till group 7 valencies. Group 4 plus minus 4, group 5 minus 3, group 6 minus 2, group 7 minus 1. These are the valencies. Now in this lesson, I will talk about the different types of covalent bonds on the basis of the number of electrons they share. Let's start with single covalent bond. Single covalent bond involves the sharing of only 2 electrons or 1 pair of electrons between 2 atoms. Single covalent bond involves the sharing of only 2 electrons or 1 pair of electrons between 2 atoms. Here's some examples of molecules containing single covalent bonds. Perfect example is H2O. I will show the displayed formula as well as dot and cross diagram so that you have better idea about single covalent bonding in H2O. Here's a dot and cross diagram between oxygen and hydrogen in water. This is water. It's hydrogen, oxygen, hydrogen. I'm using dot for oxygen here. 1, 2, 3, 4, 5, 6 hydrogen. 1, 1. You see only 1 pair of electrons are shared. So the displayed formula for this will be like this. HOH. This indicates only 1 pair of electron is shared. The single dash line means only 1 pair of electrons are shared. What are double covalent bonds? A double covalent bond involves the sharing of only 4 electrons or 2 pairs of electrons between 2 atoms. It involves the sharing of 2 pairs of electrons or 4 electrons between 2 atoms. Some examples of the compounds containing double covalent bonds. We have O2, CO2, etc. I'm showing you the dot and cross diagram as well as the displayed formula so that you have better idea about double covalent bonding in O2 and CO2. For O2, it will be like this. Each oxygen atom needing 2 electrons to complete the valence shell. First of all, I will show the valence electron for this one. 1, 2, 3, 4, 5, 6. For this oxygen, 1, 2, 3, 4, 5, 6. You see 2 pair of electrons are shared. So the display formula for oxygen molecule will be like this. O double bond O. What about CO2? This is oxygen, carbon, oxygen, oxygen, carbon, oxygen. First, I will show the valence electron of this oxygen. 1, 2, 3, 4, 5, 6. This one, 1, 2, 3, 4, 5, 6. Now we are left with the valence electrons of carbon. So this will share 2 electrons with each oxygen atom. 1, 2, 3, 4. The display formula for the carbon dioxide will be like this. O double bond C double bond O. This indicates that 2 pair or 4 electrons are shared between carbon and oxygen. Triple covalent bond, it involves the sharing of only 6 electrons or 3 pair of electrons between 2 atoms. It involves the sharing of only 6 electrons or 3 pairs of electrons between 2 atoms. Let's see the example. Perfect example is N2, nitrogen molecule. Each nitrogen atom needs 3 electrons to complete its valence shell. So both will offer 3 electrons to each other to complete their valence shell. The dot and cross diagram. Let's draw the valence electron for this nitrogen. 1, 2, 3, 4, 5. For this one, 1, 2, 3, 4, 5. There are 3 pair of electrons are shared. So I'm going to show it in this way, 3 dashed lines. So this dashed line indicates that 3 electrons are single covalent bond involves sharing of either 2 electrons or 1 pair of electrons. Double covalent bond involves sharing of either 4 electrons or 2 pairs of electrons. Triple covalent bond involves sharing of either 6 electrons or 3 pairs of electrons. The learning outcome is same for this lesson, that is describe the formation of covalent bonds in simple molecules, including molecules starting from H2 and ending on N2. Use dot and cross diagrams to show the electronic configurations in these and similar molecules. Here's the periodic table and valencies for you. Valencies of nonmetals. Group 4 plus minus 4, group 3 minus 3, group 6 minus 2, group 7 minus 1. In today's video, I am drawing dot and cross diagram of CH3OH. Its name is methanol. CH3OH. It's methanol. First, I will show the key on right hand side. You have hydrogen, carbon, and oxygen. So I'm using blank dot for hydrogen, cross for carbon, and dot for oxygen. So first of all, I will draw the dot and cross diagram. Then I will show you the display formula of this molecule. We have 1 carbon, 4 hydrogen, and 1 oxygen. But you see 3 carbons are attached to 1 carbon. This is a carbon, C, hydrogen number 1, hydrogen number 2, hydrogen number 3. And with this C, oxygen is attached. So we have oxygen here, and the last hydrogen is attached with this oxygen. Let's show their valence electrons. First, I will start with the hydrogen atoms. one for this one for this hydrogen, one for this hydrogen, and one for the last hydrogen. Let's show the valence electron for carbon. 1, 2, 3, 4. Now let's show the valence electrons for oxygen atom. 1, 2, 3, 4, 5, 6. So this is the final dot and cross diagram for methanol. Now let's draw the displayed formula for methanol. If you look at the dot and cross diagram carefully, then you will find that only one pair of electrons is shared between two atoms. Therefore, there will be only single covalent bond in this whole molecule. I'm writing the molecular formula again, CH3OH. We are having C with 3 hydrogen, 1, 2, 3. And in this, it's attached to oxygen, and oxygen is attached to hydrogen. Now I'm showing the one pair of electrons with single dash line. You see, we have only single covalent bonds between each atom. So this is an example of molecule having only single covalent bond. Single covalent bond. The next one is C2H4. C2H4. It's known as ethene. First, I will show the key on right hand side. For hydrogen cross, I'm using cross. For carbon, I'm using dot. If you look at the molecule, there are 2 carbon atoms and 4 hydrogen atoms. So we are having 2 carbon atoms. We have to attach these 2 carbon atoms with each other. This is an example of organic compound. Ethene is an organic compound. It belongs to the family alkene. There are 4 hydrogen atoms. 2 hydrogen atoms will attach to each carbon atom. 1, 2, 3, 4. Let's show the valence electron for each hydrogen here. 1 for this one, 1 for this one for this one, and 1 for this one. We know that carbon belongs to group 4, so it has only 4 valence electrons, which means it needs 4 electrons to complete its valence shell. So 2 electrons for each carbon atom will be shared with these hydrogen atoms. For example, I am starting with this carbon. 1, 2. It's left with only 2 electrons, and it needs 2 more electrons to complete its valence shell. So it will share these 2 electrons with the second carbon atom. 1, 2. Now I'm showing the valence electron for this carbon the same way I did with this carbon. 1, 2, 3, 4. If you'll see, there are 2 pair of electrons between 2 carbon atoms. I'm drawing the displayed formula for ethene. C2H4. If you look at the dot and cross diagram carefully, I've just told you that only one pair of electrons is shared between each carbon atom and hydrogen atoms, but between the 2 carbon atoms, we can see 2 pair of electrons are shared. Therefore, there must be double covalent bond between these 2 carbon atoms. So the displayed formula for this will be like this. For hydrogen atom, there will be single covalent bond. Now I am showing the second double bond with red line. This is double covalent bond. Two pair of electrons are shared. Here. Would describe and explain in terms of structure and bonding. The properties of simple molecular compounds: low melting points and boiling points in terms of weak intermolecular forces. Specific types of intermolecular forces are not required. Poor electrical conductivity. Now here are some properties of covalent compounds. Covalent molecules or compounds are gases, volatile liquids, and solids. They have very low melting boiling points or sublimes on heating. They are insoluble in water, mostly dissolves in organic solvents. They do not conduct electricity. For the solubility in water, there are few exceptions like hydrogen halides and ammonia. Covalent molecules or compounds are gases, volatile liquids, and solids. Now, what is the reason behind this? We have simple molecules with weak intermolecular forces between the molecules. Simple molecules with weak intermolecular forces. Between the molecules. We can even write molecules are attached with each other by covalent bonding. And you can write small amount of energy needed. Small amount of energy needed to break the force. Covalent compounds have very low melting boiling points or sublimes on heating. For the same reason which I have mentioned above, that simple molecules with weak intermolecular forces between the molecules or molecules are attached with each other by covalent bond. Small amount of energy needed to break the force. I am writing molecules are attached with each other by covalent bonding. Small amount of energy needed to break the force. Covalent molecules and compounds do not conduct electricity because this does not contain free or mobile electrons. Does not contain free or mobile electrons. Now exceptions, there are some exceptions. Exceptions include ammonia and hydrogen halides. These, when dissolved in water, become good conductors of electricity. Hydrogen halides are compounds of hydrogen and halogen. compounds of hydrogen and halogen.